7.3 rotations. So much like with the previous sections, it'd probably be beneficial to have your book open because the pictures, specifically the ones on the graph, I'm not going to copy over just for the sake of time and convenience, because it's just kind of a pain to copy those over. So it says use the diagram in which triangle ABC is mapped onto the prime triangle, so basically blue onto red, by a rotation of 90 degrees about the origin. Is the rotation clockwise or counterclockwise?
Clockwise. Wait.
And I'm just going to do CW for clockwise or CCW for counterclockwise as just an abbreviation, and that's okay for y'all to do as well because writing that out is long. So it is counterclockwise. Okay, it goes opposite. And I do have a clock on the wall if you ever need to look at it. Although if you don't know which direction the clock goes, then it's probably not going to be helpful because there's not numbers on that clock. In case you never looked at it. 4. Does A prime equal B prime? Explain. So we're looking at A and A prime and B prime. And so we want to know if those things are equal to each other. Anybody have a guess?
I'm gonna say no, but I don't know why.
Because the B's are like different.
They're different letters.
Well, they are different, but it is no. And that's because the distance
Different points.
between any point and its image after a rotation is not fixed. All right, the next one I'm going to kind of try to draw the picture over here to the side, but it is a hexagon. Definitely not drawn to scale. Very much not drawn to scale, but that's okay. Close enough. Close enough. So it looks like that. And so it says the diagonals of the regular hexagon below form 6 equilateral triangles. Use the diagram to complete the sentence. So number 6, and this goes with 6 through 9. So number 6 says a clockwise rotation of 60 degrees about P maps R onto blank. So if I rotate 60 degrees clockwise, where does R go? Like what other point on here? So T, S, T, V, W, or Q, which one would it fall on? Yep. It would be point S. So if it's a hexagon, we have 360 degrees divided up into 6. That means they're in 60-degree sections. We also know that because it's a equilateral triangle, so that means all the angles are congruent in that, which means 60 degrees. So there's just a couple of different ways to think about that one. 8. A clockwise rotation of 120 degrees about Q, maps R onto blank. So clockwise rotation of 120 degrees maps R onto what? And it's about Q, so that means this is our point of rotation right here.
W.
Yep. Because it's taking this whole thing and it's shifting it around, so R is going to end up landing over here because we've got our 120 degrees there. Determine whether the figure has rotational symmetry. If so, describe the rotations that map the figure onto itself. So number 10 kind of looks like an eyeball to me. It's like a... Actually kind of looks like the CBS symbol. So does this have rotational symmetry? And if so, what kind of like rotation does it have? About like what?
Yes. If 180.
Yep. Rotation of 180 degrees. Which way?
Both ways.
Yep. Either way. So clockwise or counterclockwise. About the center. So basically, if we put a point there in the middle, technically theirs looks like a little bit more of an oval than mine is really like a circle, but with the dot in the middle, I really feel like it looks like an eyeball. It's kind of creepy. 12. Does this have rotational symmetry? Nope. There's no way I can rotate that and it give me the same thing, like, around itself. Alright, this next one I'm gonna attempt to draw the shape kind of over here, but just know that you might want to reference the book for it. But I'm trying to do this because there's things I want to be able to point to with it. I think it looks pretty good. Okay. I love these labels. All right, so we're going to be referencing this picture for these next few problems here for 13 through 19.
Why did it just skip N?
I don't know. It also skipped I.
Well, that's probably because it's like a 1. They also skip
Yeah.
O. But
I don't know.
that looks like 0.
It's weird.
So. I don't know why it skipped N because that doesn't look like N either.
JKLM. I wonder if they're skipping like a letter so that you can tell like the outside from like the inside, but I don't know. It's weird. I'm like, I didn't miss a letter, did I? I don't think so. All right, state the segment or triangle that represents the image. You can use tracing paper to help you visualize the rotation. So basically, well, I don't know. The tracing paper that I used to have was like clear, and then you could like put it on top of it, and then you could like actually turn it. If you have that, like I don't mind if you use that, or If you have like those like clear sticky note things, like if that's something that's like helpful to you, because I know that seeing the rotations and stuff can be kind of difficult, you are welcome to use that, whatever. Anyways, or just get some like thinner paper that you can like kind of hold up and see it as you rotate. That's also fine, but we're just gonna do the best that we can with my iPad screen here for the moment. So 14, 90 degrees clockwise rotation of KF about P. All right, so I'm going to just try to highlight this here. So KF is here, and it's being rotated about point P 90 degrees. So it's going from here.
What does it mean by about P? Like,
That means that that's like your point of rotation. So we're going from here. It's like this part here, and it's being rotated. So this is being rotated 90 degrees around.
LH.
Yep. So it would come over here to LH. I don't know what I'm writing. I'm struggling today, apparently.
Do we have the like line above it? No.
Yeah. I was just getting ready to erase this. And trying not to erase my whole picture in the process. But yes, we should technically have that above it. All right, 16. 90 degree counterclockwise rotation of FL about H. So FL's right here, and then it's about H, and it's going counterclockwise. So counterclockwise would mean that I'm going this way. So 90 degrees around would be what?
BN.
Yep. So notice it's like over here off of H, so then it's up here off of H that way. So BM. I don't know if I have any thin sticky notes. I was gonna say you could like copy the picture onto the sticky note and rotate it over your paper, but I don't know how much that would be helpful. If anybody wants it, I can give you a sticky note though. 18. A 180 degree rotation of triangle BCJ about P.
FGL.
So let's see. Where's C? Oh, there it is. So we're looking at BCJ is right here, and we're about point P, and it's 180 degrees. So what did you say it is?
FGL.
Yep. So 180 degrees. No, I was going to say counterclockwise or clockwise. Doesn't matter because it's 180 degrees. It's going to go around the same amount either way. So either way, it's going to come and put you down here in this one right here. Rotate it all the way around. So this would be triangle FGL. Any questions on those ones? I think sometimes rotations are the harder ones to see, even though I feel like in theory they should be easier. Huh?
It's gonna take me a second to get used to this.
Yeah, it is super weird. That's the project that I'm debating on y'all doing. I haven't made it over to my parents to see if mine is still there because I feel like it would be hard to see without like an example. But it's like really cool where it's like you do different like translations on the paper and you like can choose like one of the different things to like do. Anyways, it's really fun, but I have to see if I can find mine because you would need to see an example for it to not be confusing. So, whoa. Okay. But like I said, if anybody wants a sticky note that you could like put over it and then like rotate it around to maybe help you kind of visualize it, I can give you a sticky note when we're done. Just remind me. So I don't know that I have any that are like super thin and see-through, but I can give you something at least. We're jumping a lot. Let's see. Jumping down to 30, which is using theorem 7.3, which was the one that was talking about the angle being 2 times whatever the value is that you're given to rotate it around. So I'm not going to draw like really to scale here, but I'm going to do what I can to try to give you the visual of this. So I have a line here. Have a line here.
That's a complicated one.
Wait, do we have to draw that?
No, I'm just trying to get it so you can see it. Yeah, I would just recommend you look at this in your book. I just am trying to get it so that you can see it.
Yeah.
All right, so what it's asking us for is to find the angle of rotation that maps our original onto our double prime one. Okay, so this angle in here between the lines is 35. That would be like your x value. The way that we get from here to here is 2 times x, and so from the theorem. And so then our theorem would tell us then that we would have basically just 2 times 35.
That's what we write.
Yep. So that's all the work that you really have to have for that. So the answer is 70 degrees.
Oh, that would be easy. Oh, because it's like going over 2 places instead of 4.
Yeah, pretty much. They're kind of weird. Like, I don't know. I feel like there's better stuff to do with this, so I'm just picking the highlights of this stuff out.
Why does the middle one like switch letters? It is in the book too. It's not like you did an error, but like why does it switch? Does it go from reflection to?
Hold on. I need to look at the one in the book because I know mine's not drawn correctly.
Do you see what I mean though?
Yeah, Michael, it like reflects to one side and then reflects again, which also translates to a different down.
Oh, it just reflects twice.
Which just
Yeah, it's technically, I had to go back and look at the theorem. It is a reflection. It's a reflection over the first line, then a reflection over the other line. And that is the equivalent of 2 times the angle of rotation.
Okay.
That's
Oh,
how-
we're doing rotation, but there's reflections.
Yeah, it is. That's why I had to look, and then I was like, wait, did I just not draw it right? And then I was like, wait a second. No,
So it's
it is
rotation
reflections.
and a reflection.
So this is reflected over line K to here. This is reflected over line M to here. But the theorem says that the angle of rotation where is 2 times x, where x is the measure of the acute or right angle formed by K and M. But that's given that there's a reflection over K and a reflection over M as well, or whatever your lines are.
Okay.
basically 2 reflections equals it going down.
Yeah, 2 reflections equals 2 times the angle,
Okay.
basically.
I don't want to do this next one. Can we skip it?
Which one?
31.
Oh, that's y'all's homework.
Okay.
Wait, can we do that one?
Can we do 31 actually?
No, why would we?
Yeah.
Why
Yeah, for homework you can.
Oh.
Find the value of each variable in the rotation of the polygon about point P. 34. Again, you don't need to copy this. I'm just gonna attempt to so we can look at it a little bit better.
You should.
Hopefully you can already see why you don't have to copy this. This is another one where you need the not drawn to scale thing, you know. Anthony, you with us over there?
Right, he's sleeping.
He's asleep.
He
I
probably
guess-
fell
I guess
asleep
that
when he
means
came to
no.
the platform.
Oh,
Is he actually snoring?
No, that was.
No, that was.
Oh, I was like, whoa.
In science class, Colton was sleeping and Mrs. Fox just started throwing markers at him to get him to wake up.
I thought about it.
Idea.
No, I had a teacher in high school or in middle school. We'll go back to this in just a second. Kid fell asleep. Well, first of all, kid was super out. He had his head down and he went behind and he took a marker and he drew a smiley face on the back of his neck. And then after that, he walked up to the desk and he's like, wham! Right beside the guy's head because his head was laying on the desk. He didn't sleep again after that. It's quite funny.
If that happened to you, you would not think it was funny.
I actually would. I think it's weird.
Hey, Greg.
That's good. I think
I got
Dave
scared in
Blair
class.
can
I
do
got
like
drunk.
the early game on Thursday.
Okay. I never put it up on the board, but I'll make a note so that way in case they don't get it covered, then I'll let you know. Or if they do get it covered, I will let you know. Concessions again. Okay, cool, thank you. Alright, so this all, it went away. Come back. So this all the way around, they're saying is 110 degrees. Alright, so we're solving for each of the things. So we have to solve for A, B, C, D, and E. Okay. So, with A, I know that the entire thing is 110. My formula, or my theorem, says that basically we have whatever x is, 2 times x is equal to the whole thing. So that means that A, or 2 times A, is equal to 110. So A is equal to what? 55, so that's the first one. A is 55 degrees. Now working my way around, solving for B, I would set it up to be 3B is equal to what? Yep. So it's rotating around, so that means that this side finishes over here, so 3B is equal to 12, so B is equal to 4. And then C over 2 is equal to what?
14. Or 7 at the answer.
Okay, I was like, 14. Where'd you get a 14 from? C over 2 is equal to 7 because, again, if we rotate this around, the 7 is going to line up on top of here. Multiply by 2, so C is equal to 14. I'm going to work over this way now. And then what about D plus 2?
2 equals 10.
Yep, so again, rotating it around, that comes over here to the 10, so 3 plus 2 is 10. So we subtract the 2, so D equals 8. And then E, 4E minus 2 equals what?
5.
Yep. So then add the 2, 4E equals 7, divide by 4, so E equals 7 over 4, and you can just leave it like that. or you can rewrite it if you really want to, but I would just leave it. Any questions on that? I know it's a lot. It might help to have a sticky note that you can rotate, or to like actually literally take your paper and like stick it on here and like take it and rotate it around so you can see what's happening. That might be helpful. Anyways, however you need to do it to visualize it, because I know that's kind of a lot to see happening.
Rotate your head.
I pull it out.
Let's see, we're gonna look at one more thing here with the wheels. 36, we have the wheel hub of a tire. There's like a hole in the middle. Alright, it looks something like this. All the holes are the same size on the outside. Just ignore the fact that mine are not all the same size. And it wants us to describe the rotational symmetry of the wheel hub. So it wants us to say how it's mapped onto itself, if it is at all. So I know this has rotational symmetry, so how can I rotate it so that it maps onto itself? Excuse me.
It looks like any degree.
How much?
Like any degree that's like goes until it's 90, so like 45, 90,
Oh, yeah.
whatever's next,
I
180.
thought you said an 80 degree, and I was like, it's very specific. So I can rotate this from here to here. That's 45 degrees. Another around would be to 90. And then we could go to 135 and then all the way around to 180. Remember, at 180 we would stop. We only are going up to 180. So yes, obviously I could keep going around, but that's where we would stop. So we could say in the clockwise or counterclockwise direction, or I guess I should say clockwise or counterclockwise rotation. Let's get more specific here. Of 45 degrees, 90 degrees, 135 degrees, or 180 degrees. So every 45 degrees up to 180, it would be a rotation there. All right, any questions about those? All right, some problems. Like I said, don't forget we are looking at a quiz on Wednesday on this, and probably a vocab quiz on Friday, I mentioned the other day. Huh?
Is it gonna be another crossword?
I'm not sure yet. TBD.
Crossword with a word bank.
Not gonna lie, it depends because last time.
Well,
that
a
was-
crossword with a word bank is, unless a bunch of the words have the same amount of letters, it's pretty much a free 100.
Is that
That's what I do it.
I like that
this
idea.
I like that idea.
Bad idea. I've been out for a week. I need
It's
I'll be like, you only have 10 words on there, but I'm giving you all 19 in your word bank. You have to really figure them out.
no,
Yeah,
actually,
I mean, that wouldn't be bad.
Honestly,
That wouldn't be
that's
bad.
an idea.
I'm like, that wouldn't be bad.
We will see.
Just an idea.
All right, 7 through 19 odd,
Okay, bro.
and then 31, 35, and 37. Actually, don't do 38 instead of 37. 37's degrees are very odd because of the amount of wheels in the hole. So do 38 will be much easier.
wait, 38 instead of what?
Do 38 instead of 37 because 38 will be way easier than 37.
No, you
Yes.
When is the video for 7.2 gonna be out?